All right, so let's just work a few examples using the AC method. Factor each trinomial. All right, so let's start with 9x squared minus 21x plus 10. Okay, so take a second and maybe try this out on your own. Okay, so we need to first calculate AC. So we'll take 9 times 10 equals 90. Now, what's nice about this AC method is that our sign rules still apply from when we were just doing the simple polynomial x squared plus bx plus c. So when AC is positive, but then we're trying to add up to a negative, that's going to mean, okay, both factors must be negative. So negative times negative is positive, and then they add up to a negative number. So we can just focus on the negative factors of 90. All right, so obviously 90 equals, well, so negative 9 times negative 10 are options. We might kind of start at the bottom and work our way up. So minus 1 times minus 90, minus 2 times minus 45, minus 3 times minus 30, minus, not divisible by 4, minus 5 times minus 18, minus 6 times minus 15. We already got minus 9 times minus 10. And anything else we could do? Then we just start to repeat. So those should be all of our possible factorizations. Now think of, okay, which ones would add up to minus 21? Minus 9, minus 10, minus 19. Nope, that one's out. Minus 1, minus 90. Okay, that's pretty obviously too big. Minus 2, minus 45. Minus 47, again, way too big. Oh, look at that. I want to go through the whole list. Minus 6, minus 15 does get us our minus 21. Okay, so we want to use those ones. Step 2. So now remember, we're not ready to factor just yet. We need to split the middle term. So we're going to take 9x squared minus 21x plus 10. Then we need to rewrite it as 9x squared, let's say minus 6x minus 15x plus 10. Right? So we've just split this up into minus 6 minus 15. All right, now we use grouping on this thing, so we're going to group the 9x squared minus 6x plus the minus 15x plus 10. All right, so this term will lead us. We can get a 3 out and an x, so that would leave behind 3x minus 2. Now we need to factor something out of minus 15x plus 10 to make it match the 3x minus 2. So I'm going to say we factor out a negative. Looks like we could do a negative 5. So if I divide minus 15 by minus 5, that leaves a positive 3x. And 10 divided by negative 5 is negative 2. Perfect. Now we just need to factor out the common factor of 3x minus 2. And then the leftovers are 3x and negative 5. That's our factorization. All right, let's try, how about a 3z cubed plus 10z squared plus 7z. Okay, so take a second, take a look at this, pause the video. All right, so what do you notice about this trinomial here? Maybe that there's a common factor of z in all the terms. So I'm going to take a z out first and get 3z squared plus 10z plus 7. Okay, so that kind of simplifies it a little. Now we need to look at the 3z squared plus 10z plus 7, use our AC method on that one. So AC is 3 times 7, positive 21. Okay, so we know we've got to multiply to a positive, and then they need to add to a positive, so we're looking for 2 positive factors of 21 that add up to 10. And this one actually looks like we kind of got it right there, right? 3 plus 7 happened to equal 10. So that's pretty nice. Okay, so then we'll start to do our grouping method on it. So I have 3z squared, maybe I do plus 3z plus 7z plus 7. Just splitting the 10z into a 3z plus a 7z. All right, and then maybe notice that, so these two terms we could factor out a 3z. That would leave z plus 1. And out of these two, we could factor out 7. And that would leave a z plus 1. Awesome. Because now z plus 1 is a common factor. Factor that out, and we're left with 3z plus 7. All right. So that z times z plus 1 times 3z plus 7 is the full factorization of our original polynomial. Always remember, be careful to keep any GCFs that you got, because that is actually part of this. You have to have that in there for this to multiply back to the original. All right. Let's try a couple more here, then I'm going to call it a day. So let's look at maybe an example where we mix in some other variables. So let's do 6x squared plus 5xy minus 6y squared. All right. So again, with this one, I think it is useful to ignore the y, or not ignore the y, but think of the y as going with the coefficient, as being kind of another number, and then focus on x for the AC method. So we still use a, b, c. Keep a y with your c. So first, when we look for AC, I'm going to calculate AC as 6 times a negative 6y squared. So that equals minus 36y squared. All right, using our sign rules. So think of, we're trying to factor this out. Each factor should have a y with it. So let's see, I have a negative c and then a positive b. So that means I have one negative factor, one positive factor, and, not negative c, a negative AC. So I have a negative factor, a positive factor, and then they got to add to a positive. So the positive factor needs to be bigger. Okay, so let's think about that. Maybe start with a negative y times a positive 36y. That's a little too big. Okay, then we look at maybe do a negative 2y times positive, spacing out, 18y. Again, a little too big. Positive 16y. All right, but we're getting a little closer, narrowing it down. Let's do minus 3y times 12y. That's going to add up to a 9y. Okay, we're pretty close. Maybe we do minus 4y times 9y, and minus 4 plus 9 equals positive 5. Okay, so that is our factorization. So let's split it up. So we do 6x squared. I'll do a minus 4y plus 9y. Oh, shoot. 6x squared minus 4xy plus 9xy minus 6y squared. All right, and then group them up. So 6x squared minus 4xy y plus 9xy minus 6y squared. Okay, what can we factor out of here? So we can get a 2 and an x, I think. So 2x, we're left with 3x minus 4y. Oh, 2y. Making all kinds of mistakes now. Okay, so then here we could factor out 3 and a y. So we'll have a 3x minus 2y. Aha, yeah, and they match. So that looks good. Okay, now the 3x minus 2y is the common factor. And the leftover parts are the 2x and the plus 3y. And that's our factorization. All right. So finally, let's look at a little bit different example of a, what is it? I guess it's D on this one now. A little bit different example. It's kind of a variation on this theme. So x to the fourth minus 3x squared minus 4. Let's try to factor this. So this is a little different than our other trinomials because, so it's a trinomial, it has 3 terms, but what's different is that our leading term has a 4th power in it. So how will we deal with that? We only know how to do it with an x squared, right? So here's that substitution trick that we talked about a little bit before. Maybe let's see what happens if we'll define a new variable u and let u be equal to x squared. Okay, so then notice that if I square u, and that's x squared squared, which we know is x to the 4th. Okay, so this is nice because now look, I can go back here, I can replace an x squared with a u and an x to the 4th with a u squared. This becomes u squared minus 3u minus 4. Now this looks like a polynomial or a trinomial like we've been working with. So now we just need to look at, okay, what are the factors of -4 that are going to add to a -3? Well, it's going to be the one where the negative factor is bigger than the positive factor. And it looks like -4 plus 1 would add up to a negative 3 multiplied to a negative 4. So write that out. That's going to be u minus 4 times u plus 1. Okay, now remember though that u is actually equal to x squared. So we want to replace that back in. X squared minus 4 times x squared plus 1 is the full factorization in x. Okay, so for now this is done, but it'll actually turn out this thing is something that factors pretty nicely into x plus 2 times x minus 2. And then x squared plus 1 is prime. So this would actually be the complete factorization. But do think of that. If you ever see a higher power in your trinomial, maybe this trick of substitution could help you factor it out with our methods from before.